All right, hello. My name is Cole Dobbin-Speck, and this is a review of Sprint 1 for my program for IST 361 called RADAR, which is the Red Team Analysis, Documentation, and Automation Revolution. So first things first, it's on GitHub. The link is up above on the screen. The main objectives for this sprint were to build the core client functionality. And this means like running commands and getting the output. It's going to be a command line tool that users are going to interact with. The other part was building core server functionality, so having a server with a basic API that can be interfaced with by the client in order to send and receive data. And then the last part of the sprint was testing the client-server interaction. So all of those things have gone pretty well, and I'll show that off in a minute. But coming next in the following few weeks is going to be more functionality for both clients and servers with command parsing, automation functionality, that's in the name of the product, more configuration, so having configuration files that the client and server can read from, as well as refactoring the code to make sure it conforms with good design patterns. Alright, and for the user-facing demo, I'm just going to minimize this and open up my command prompt here. I'm using PowerShell for this demo, but it actually will work the same on any type of shell if it's the standard Windows command prompt or Bash if you're on Linux. All I need to do to start the program is using Python, launch the client, since this is a Python program. There also needs to be an instance of the Radar server running, so I'd put that after the client. However, since I don't want to run a dedicated server, I can actually say I want to start a local instance of the server by doing !start_local. Then when I hit enter here, it is going to start the server, and you can see some debug messages print out for that. And then after that started up, it's going to start up the client, which is going to then connect to the server and make sure that the client and server can communicate with each other. If your client is not already authenticated with the server, it's going to do that automatically. And now it's fully started up and ready to be used. So you can see I landed on the Radar command prompt. It says Radar here, and then it lists my current directory. Similar to the prompt up above when I was in normal PowerShell, but obviously this says Radar. What I can do here is enter commands as if I was on the normal command line. So I could use dir to list the contents of my local directory, which is essentially just going to be the files I have in my program. But I can launch really any command I want. So I could change directories, and just to show you that the output does change here, so this is just the contents of my C drive. But I can run really any command I want. So I can run nmap, which will actually check a network device for any open ports and services running on it. So you can see on my local host, there's a bunch of ports open, and this is part of what a pen tester would do when trying to assess a system. So you might have seen the debug messages pop up that the command is synced with the Radar control server database. And what that means is actually every time it's running a command, it's sending the output back to the database to be saved. So, in addition to the normal commands I can run as part of my operating system, I also have additional commands. One of those is dblist, where I can then actually show the data in the database in my command prompt. So saying like radar dblist raw commands, this is the raw is the name of the database, and commands is the name of the collection. Collections are kind of like tables in my SQL databases. I can hit enter here, and since I'm authenticated with the server, it is going to return the data to me. And you can see here is the previous commands I ran. So I ran the dir command, and this is the output for it. It looks pretty ugly because it is a single string rather than multi-lines. However, that JSON could be then parsed out to rebuild what it originally looked like. Same with Nmap, you can see the full output, and this is the basic functionality that I was testing with the client to server interaction. Alright, and when I'm done working with Radar, I can just exit out of it here by just saying exit. And what that's going to do is it's going to shut down the local server that's running, and then just put me back on the default command prompt, or what command prompt I was using before. And for the code, I'm using PyCharm for that. It is recommended when developing Python to use PyCharm. So there are three main files that make this program functional, but this method is the main functionality of the client. So if you change directories while using the Radar prompt, it needs to update since it shows your current working directory. And then it just has a loop. And what this loop does is it grabs user input, and then as long as the input isn't blank, it is then going to reload the utilities module, and then run the command. So when reloading the utilities module, it does that so if there's any changes for how commands are processed, it actually makes those changes functional immediately. So that means you don't need to restart the client while adding more functionality. When you run a command, it is going to use the most up-to-date version of the code. This is a statement that checks to make sure the user input is not one command, any of the commands that are intercepted. So these are commands such as change directory, exit, or any command using the radar keyword. And if it does detect that the user input should be intercepted, it's going to send that to the method to process that and then exit the loop, so that way the rest of the code is not run. So if it's not run as an intercepted command, then it should be run as a system command. So it's going to run it here using the utils module, save the results to a variable, and that variable is then used for two things. One is it's going to be sent to the database to be saved, and the second is that it's going to be printed out so the user sees the output that they're expecting. The main method here is pretty simple for the client. It just checks to make sure that the server IP address or starting local server is specified. One of those needs to happen, and then it handles it appropriately. The utils module is a major part of the client here, and this is where a lot of the core functionality of the client originates. So this is the code for running a radar command. It takes in the command to run, so this is like the full user input. It just splits it up because it needs to figure out what command is actually supposed to be run. And then there's a bunch of different commands here. I only showed off the dblist command, but there are other ones that work as well. This is the method that actually runs a system command. The way this works is it actually creates a temporary file. So this is just in like the temp folder, wherever that is on your operating system. And then it runs a sub process that executes that command. So that process, it runs in your system shell and redirects all output to that file. Once the command is done executing, the file is then read back and then returned. And as soon as you close the temp file, it actually deletes itself, which is a nice part of the temp file library that I'm using. This is an example of what a method that interacts with the server looks like. So it builds the full URL. This is just like if it was a web page, and then use the requests library to send a GET request or a POST request in some instances to the URL. and then it checks to make sure it has been a successful request, and if so, it then runs whatever code it needs to. This method is just checking to see if the user is authorized or not, but something like the send raw command output method will actually be inserting data into the database. So if that's successful, no action is needed other than printing out that it's successful. So for the server, I'm using two main libraries to give it its functionality. They are Flask, which is a web server library that is great for making APIs like I'm doing here. And then I'm also using PyMongo. PyMongo is a library for interacting with a Mongo database. You can see here there's a default configuration. So this just specifies how to run the server and where the database is. And let me go find a method that is cool. All right. So this is the method that actually gets data from a database and collection. So on line 87 here, there's app route, and this specifies a path like on the web server that actually calls this method. So if I were to browse to the server at /database/ whatever name I want, so in my example I said raw, and then the collection name, which in my example was commands/list. So then if I browse to that address, it's then going to execute this method. What this method does is it makes sure that the database isn't protected. So obviously I don't want this API accessing like user names and passwords. The next thing it checks is for restricted databases, and these are things that only administrators should be accessing through the API. But if the user has permissions for that, then it's going to open the database from the Mongo client, which actually connects to the database, and that's really easy with the library I'm using. All I need to say is the database client, square brackets, and then the name of the database. Same thing with collections. All I need to do is to access a collection that's in a database, I just need to use the database variable, square brackets, and then the name of the collection. Then, in order to get all of the data from that database, I am just, from the collection object, I'm using the find method without any filter. So this is just basically like select star from database. It's kind of like that in MySQL. Once all the data is returned, it then converts it from BSON, which is the way Mongo stores data. It's similar to JSON, but not quite. It converts it from BSON into JSON, and then returns that through the web. Flask also supports like post requests, so this method inserts data into the database, and it's pretty similar, except it's reading the payload of the post request and decoding that. You can see I do like a similar access for the database and collection, and then on the collection I do insert one time this JSON data. So this is the method that actually starts the server. This part right here just makes sure that the output for the debugging or errors is going to the correct place. So in my example, I have it outputting to a log file. So essentially that's what that part of the code does. It either outputs it just to the console or to a log file depending on these optional parameters. Once it's outputting to the correct location, it then connects to the database. So the database client is set to connect to whatever the database is in the configuration. Very straightforward there. And in case it doesn't succeed, does a quick try to make sure that it can actually connect to the database and return information. If that succeeds, then the program continues, and then the actual web server gets executed here. So it's just one line, like start the web server. And this is why I'm using Python. It is just so much faster, so much easier to get work done than something like Java.